Today we're just going to continue to look at systems of linear inequalities applications. These are just going to entail 3 inequalities today versus the ones we looked at yesterday with just 2 inequalities. So the gymnastics team is selling t-shirts and pajama pants as a fundraiser for the team. They're selling t-shirts for $10 each and pajama pants for $15 each. The goal is to make at least $3,000. They only have 150 t-shirts and 150 pajama pants to sell. So we have to think about our restrictions again. What are our restrictions in this scenario? So our first restriction is that we want to make at least $3,000. Okay, so we can set up an inequality to represent the cost of the t-shirts, the cost of the pajama pants, and how much money that's going to bring in. So since t-shirts are $10 each and X represents t-shirts, that would be written as 10X plus the pajama pants, which are $15 each, so that would be 15Y. Both of these are rates. Both of these go with 3,000 because we're talking about the money. Now, her goal, or the goal, is to make at least $3,000. So at least is one of our key words, which means that we want to make more than or greater or equal to $3,000. So greater than or equal to. Okay, so $10 per t-shirt plus $15 per pair of pajama pants. Those are both rates, need to be greater than or equal to 3,000. That's our first constraint. Now we have 2 other constraints. This is where the 3 inequalities is going to come into play. So they only have 150 t-shirts. So what does that mean? That means they can't sell more than 150 t-shirts. It is a total, but it's not total combined t-shirts and pajama pants. It's just the t-shirts. So t-shirts was represented by X in this scenario. What does X need to be? It needs to be any number that is less than or equal to 150. Okay, 150 is the maximum because that's all that they have. So they're not going to be able to sell what they don't have. Then for the pajama pants, it's the same scenario. There are only 150 pajama pants to sell. So pajama pants is Y, and that needs to also be less than or equal to 150. And this is my system of inequalities. So now we're going to graph it. We're going to answer a few questions about it. So to graph it, you might, again, want to utilize that being able to click and unclick the lines because there's just a lot happening in Desmos when you put all 3 lines together and to be able to see which one is which. I'm going to actually start with the vertical and the horizontal because those are pretty straightforward. Remember that this is a scenario where we are not going to be selling negative t-shirts and they are not going to have negative pajama pants. So we want to make sure that everything remains in the first quadrant. So for the pajama pants, the least number, or the most number that they could sell, is 150. So that should have been just a horizontal line at 150. Now the other side can have an arrow because this could keep going past 300 on my graph. The shading is where the solutions are. So this line can continue on, but that doesn't mean that my solutions fall over there. The solutions will just be restricted to the shaded region. Then for the x-axis, it also hit at 150. These are going by 30s, so 150 would be right here. And this is just a vertical line. All right, then for my last inequality, my y-intercept is at 200. So again, it's probably easier to look for the y-intercept every single time. So that's going to be right below 210. And then my x-intercept is at 300. So that would be here. Oops. And then this is a solid line. So that's what it would look like. And then the shading would be in this middle triangle right here. Okay, so anything in that region, and I know it seems small, but my scale is so spread out that if I zoom in, I can see a lot more options for the number of t-shirts and pajama pants that we can sell and still be within that constraint. Okay, so is it possible for the gymnastics team to sell 95 t-shirts and 130 pajama pants? So there's two different ways to be able to tell if a point is a solution, and this goes for D as well. You can either plug the point into Desmos, plot it, see if it's in that shaded region. You can look at it on the graph. Again, the graph is going to be a little bit harder to see on here now because of our scale, but you could still plot the point. You can also plug it into your inequality. So we know that it's okay for them to get 95 or sell 95 t-shirts because they have 150. We know it's okay for them to sell 130 pajama pants because they have 150 pajama pants. But is it going to get them their goal of $3,000? So we can plug in, it was $10 per t-shirt. And then it was $15 per pajama pants, and see if that is in fact greater than or equal to 3,000. So if I plug this into the calculator, I get 2,900. So $2,900 would be how much we make, which is not greater than $3,000. So even though it fits our constraint of how many t-shirts and pajama pants the gymnastics team has, it does not fit the constraint of how much money they wanted to make. So this would be a no. For part D, the X value, which represents the number of t-shirts, is 160, and it's asking if it's a solution. Well, you can plug it in like we just did. You could check it on the graph, but they don't even have 120 t-shirts or 160 t-shirts to sell. The maximum number of t-shirts that they had was 150. So this would be a no. And for your reasoning, it could be because it's not in the shaded region. It could be because what we just said, they don't have 160 t-shirts to be able to sell. Either one of those explanations would be fine. Example 2, you're fishing for bass and carp on Lake Lanier. Gaming laws allow you to catch no more than 10 bass per day and no more than 15 carp per day. You're also restricted to catching no more than 20 fish in total per day. Let X represent the bass and Y represent the carp when we set this up. So we have 3 restrictions here, hence the 3 inequalities. So one of the restrictions is the number of bass that we can catch per day is only 10. The bass is X. So my X value, I can catch no more than 10 bass per day. So that would be less than or equal to 10. Okay, then I can catch no more than 15 carp. Carp is Y, so my Y needs to be less than or equal to 15. Then for my third inequality, I'm restricted to the total number of fish that I can get. Well, what are the fish that we're fishing for? It's bass, which is X, and carp, which is Y. So in total, that would be represented by X plus Y, the total number of bass plus the total number of carp that I can get all together needs to be no more than 20 fish. So that would also be less than or equal to 20. So to graph this, I'm going to start with the X and Y axis again with my vertical and horizontal lines, just in terms of how many bass I can get and how many carp I can get. So the first one for the X axis, that was the number of bass. It needed to be less than or equal to 10. So I'm going to put a point at 10. Try to make that more straight. Okay, then for the amount of carp, that was 15, so that would be in between 14 and 16, and that's going to be a horizontal line. And then x plus y is less than or equal to 20, has a y-intercept of 20, and also an x-intercept of 20. Okay, and then for the shading, this picture kind of shows how difficult it is because I see shading almost everywhere except in that top right. You can change the colors of the shading in Desmos as well if that helps you to be able to visualize a little bit better where that overlap is. But we need to be less than all of these lines. So I need to be less than my vertical line, I need to be less than my horizontal line, and I need to be less than my diagonal line. So that would mean that we would fall in this area for our solutions. And again, be careful, we're restricted just to this first quadrant. We're not going to have negative bass or negative carp, so everything should remain positive. So determine a solution to the system and explain what it means in context. Anything in the shading, but then with the context, talking about the bass and the carp and how many fish we're getting. So we could do 4, 6. That would be a solution. So 4, 6. And then what does that mean? That means that we can get 4 bass and 6 carp. Okay, and that would fall within all of our restrictions. It would be less than 10 bass, less than 15 carp, and less than 20 fish